prompted. So I'm going to welcome our next speaker, who is Jared Mair. Jared's the Chief Insights Officer from MPI. There he is. I had a moment there where I thought, is Jared here? But he is here. So Jared's the Chief Insights Officer at MPI, and he leads MPI's Insights team. So we're sort of continuing on this theme of context. What's the context that we're operating in? And we're going to keep this theme going all the way through to morning tea. So MPI Insights team takes a system view to how we track and analyse impacts from a number of things like geopolitics, trade, market shifts, new technologies, value chain enhancements, emerging business models, farming systems and inputs, and maps the implications back onto the New Zealand food and fibre system and the broader economy. So please welcome Jared Mair.
Sorry. Anyways, if you speak before, I can go longer, so I was just checking my time limit. So there's a real theme here today, and so what I'm going to do is I'm a wanderer, so if I'm getting in the way, tell me to move out of the way. So what I want to do is sort of build on the conversations that we had in the past sort of hour or so, and then try and extrapolate what that means for New Zealand and how that's changing. And I'm going to stay on this side because that's really bright. And how we might think about what that means for New Zealand's farming systems, for what we produce, and how we think about how that changes our positioning as a country and what we do with our food. So when we think about the global food system over the last 12 years, a lot of people focus on the actual alternative proteins or food companies that are starting up or those that are raising capital. But in actual fact, when you look at where the actual investment's been over the last 12 years, it's been in the platforms, the capabilities, and the systems that deliver the food to the consumer in the last mile. So if you think about individual foods, that's not even 10%. But yet that's probably 80% of our focus. When we think about the bits that actually create value, the ability for us to actually compete and how we think about how those technologies flow through our system, we're just not even having that conversation at the moment. So what I want to do is sort of talk to you about how those technologies are developing and then sort of show you or sort of talk about how they might flow through, how we think about how that food system is going to change and how it's going to impact New Zealand as a whole. So I'm going to start with AI. We're then going to come down a little bit lower and talk about some of how that's impacting the global food system. Then we're going to talk about some applications that are actually happening on farm globally today. So we think about the progress of AI, and we talked about the concept of the flywheel. AI is a compounding flywheel across the entire global economic system. If you went back about 18 months, the average LLM was roughly about equals intelligence to the average American, about 98 IQ. If you jump forward about another 6 months, so a bit earlier this year, right at the beginning of this year actually, really at the end of the year, it was roughly as equivalent to, or AI could beat, a person who had a PhD, an IQ of 140, was using Google, trying to answer a question that they didn't know the answer to, and the AI could beat 80% of the time. If we jump through to the middle of this year, LLMs could beat anyone with a PhD with 140 IQ, using a Google tool, answering a question they didn't understand. So that's the rate of progress. That AI is now translating into how we think about what we discover, how we explore things, how we understand how things are put together, and how we understand nature. I'm using the example there of CRISPR because it's a valid or relative conversation that we're having at the moment in New Zealand in both a political sense and also in our production sense. So CRISPR, if everyone is aware, is a genetic editing tool. But what we've got now is AI designing the proteins that both point and cut the DNA strands themselves. So what does that mean? It means we actually know how to find those cuts faster. When we make those cuts, they're more persistent, so we don't have to go through multiple generations, and we actually have more certainty about the outcome of that process. That is going to accelerate. Taking a step forward, another step. When we understand when we've got this intelligence that's coming through, we're now in the process of trying to give that intelligence a body. So when we understand robotics and humanoid robotics, what we're actually trying to understand there, and we've talked about a bit about economic growth, but one of the key issues that we've got globally is a lack of workers, and a lack of workers to undertake certain tasks in particular. So how do we understand that? At the moment, there are about 5,000 Optimus 2 robots in training in Tesla factories right now. And why is that significant? Because they are a polymind. And what that means is each one are learning different tasks, but collectively they're all learning all those tasks at the same time. The reason we think this is important because we believe that these robots or similar capabilities will be in the New Zealand milking shed milking cows within the next 10 years. We believe they will be picking fruit in New Zealand orchards within the next 10 years. There are already examples where they are now training these robotic systems to not only be identify and harvest fruit, but also undertake the pruning tasks themselves. So let's explore how AI is actually now starting to shape more directly the food system, and in particular, how we understand it. So when we think about AI, we think about it in three ways. What's out there that we can use to execute with? Where are the gaps where there is an opportunity for us to create IP by which we might be able to exploit in a global market? We heard a bit of a concept about that before. And then thirdly, where are the black holes? Where are those capabilities that can extract economic rents from the system that we either need to learn how to live with or to avoid completely? The first one here is a black hole. So Forager is the system, Brightseed is the company out of America. What they've done is taken 140,000 plants, they've put it into that system. Their aim is to get to 270,000 plants. What they want from that is essentially to map through and understand how to grow that plant, where they can grow it, what they can process it into, and what are the compounds that can come out of that. They've then combined that with all biomedical research and all medical research. Purpose being is if you can identify a human condition, they might be able to find a solution for you. The first product that they did was a gut health product, and they did that in 3 months, which would normally take about 7 to 10 years. In that process of identifying where that source material came from, it turned out it was a waste stream, and it was a hemp seed husk. That is a black hole. How do you compete against a company or a capability that can control the IP around 270,000 plants? That's what we're looking at. Second one, taste-wise. So if you understand the global food system, 80% of all SKUs in the supermarket are controlled by 10 companies globally. That's the degree of consolidation we've got in the system. 8 of those 10 companies are using this system to understand what you do and how you consume food. What are you talking about? What are you eating at restaurants? What are you looking for when you're looking for recipes online? And they're using that as a trend set to understand what foods they're going to push to you in the next 6 to 12 months. If you understand the rate of innovation in the global food system, we actually have between 8 and 10,000 new products put on the shelf every year. This is going to accelerate under the use of these technologies because they can innovate that much faster. So keep moving on. Helios AI. So that's a commodity forecasting tool overseas at the moment. Essentially what they're doing is they are using the mapping geopolitics. They've got a digital twin of the global weather system, and they are able to project forward commodity prices 12 months in advance. Now, it's not every commodity at the moment, but it is expanding and will continue to expand. Price certainty around where those products are, how you got what ones that people are looking for, and how you might accelerate the process to develop them are going to be key features of the future food system. Moving forward, let's think about what happens on farms. In the past, what we've done to increase our productivity was put more things in. By putting more things in, obviously we could get more things out, but there were consequences or there were costs for us to doing that. First product there is a second generation product. So what they're actually doing there is they've found a bacteria that enters the plant, and when it does that, it can extract up to 50% of that plant's nitrogen needs out of the air. It cannot leach, cannot oxidize, And once it's in the plant, it's there. Why is that important? Because you can therefore apply it and it'll be there for next season as well. This is currently on 2 million acres in the US right now in the vegetable sector. There are other products that are also doing a similar thing in that at the moment, but what they're doing is they're using an endophyte type bacteria that attaches to the seed when it germinates, and it does a similar thing. Those products as a whole have already pulled out 550,000 tons of nitrogen out of the Gulf of Mexico already over the last 4 to 5 years. When we think about when we produce food, we put a lot of pesticides or herbicides into the system. Why? To control, obviously, product loss, control waste, and increase our productivity. Again, we are now developing systems that don't rely on any inputs. So this is using ultraviolet light to control fungal and microbial impacts on strawberries. Similarly, now we're at the second generation of agrivoltaics, where now we can actually use the voltaic system themselves to control the quality of the wine or the attributes that we want out of the wine. Reducing 30% of water input, creating an additional revenue stream from the energy source itself, and creating a more holistic system in terms of what we think about what we do on our farms. The key point around this is that what we've done in the past isn't what's going to be done in the future. These are all products that are out there and available today. Let's keep going. When we step back and we understand the New Zealand biosecurity system, we have got one of the best systems in the world. But in saying that, we've still got enough pests in New Zealand today that it's costing the New Zealand economy about $9 billion per year. Now, we control that through pest control, we control that through pesticides, which are some herbicides. What we are seeing now is the advent of synthetic biology. Does anyone understand what synthetic biology is? A few nods, okay. Essentially now we're designing peptides that can target particular insect species. This is the first one we've seen of relevance to New Zealand. This just got approval in the US in September. Essentially what it is a product that can wipe out varroa mites and leave other insect species alone. What we're seeing is a change of the systems and inputs that we can use into our systems. This took 3 years to get through the system. So that's roughly the speed that it is. When we think about how that's progressing in terms of other parts of our system, we're also now seeing they've just put through an application for powdery mildew. Again, shifting from insecticides to pesticides and to fungicides. How we understand these tools and how these tools will be able to use in New Zealand have a significant impact in terms of our competitiveness going forward. If we could wipe out $9 billion of pests out of New Zealand economy, we need no more land. We need no more capital investment in processing capability. We don't need to find an additional consumer. It's roughly equivalent to the size of the meat industry. Let's keep going. Some people know the seed industry quite well. But if you're not so familiar, New Zealand exports counter-seasonally all the carrot seed for the EU. So if we don't grow the carrot seed in New Zealand, the EU next season gets no carrots. It's roughly about $220 million worth of exports. The first robot there is a Verdant Robotics that's sitting in California. That is equivalent of about 80 labor units. 95% less inputs and about 2 to 3 times more productivity. What it does is it can track every carrot plant up to about 500 million per block or units that you're doing. It zaps the weeds, fertilizes the ones that it needs to provide fertilizer to during its growth, and is currently in the process of being rolled out. So when we think about our food safety, if we can reduce inputs into our food systems by 95%, we start to change the conversations around how we think about what we're producing and also how we're producing it. Moving on, we've been tracking this process out of it's the University of Austin, Texas for the last 4 years. 5 minutes, okay. Essentially what it is a biofilm biomass that essentially can absorb water out of the air, so it's just drawing it out of humidity. And what it does is it's $2 to produce, it's 100% biodegradable, lasts 7 years, and produces 14 litres of drinking water per day per kilogram in average humidity. At what they call dry humidity, which is roughly 30% humidity, it produces 6 litres of drinking water a day. So areas that we haven't been able to produce in are effectively going to be able to go into production, or our resilience of our system when we think about the impact of climate is about to change. They are currently in the process of scaling that up into a commercial scale production facility, and they are targeting agriculture. So when we think about what we can do, a ton of that stuff sitting in a 20-foot container, sitting on top of a hill, will provide 14,000 litres of drinkable water a day for either irrigation, stock, or reticulation. When we think about tools, and we've talked about a little bit about AI and how that's changing capabilities on farm, this is the first system that we've seen that is multi-purpose. So in the past, we've seen robots on farm that do particular things. This is your tractor. That little red V shape underneath there, that's where you connect your hook. It'll plow, it'll mow, it'll do all those things that a normal tractor can do. Why is that important? Because again, we're taking a labor unit out of the system, but in doing so, we're increasing the productivity of our system in terms of what we produce. How we've done things in the past is about to change. All of these things are either being commercialized now, or you can buy them off the shelf. We've talked about the agri-tech sector. When we understand the productivity or the productivity of our underlying food system, we averaged around 2 to 2.5% per year. When we look at agri-tech, it's been roughly around 15%, 12 to 15% per year. Biocon is running at 24 to 25%. When we think about what New Zealand's food system is, we actually need to understand and also include our bioeconomy. Aurora, a company in Auckland, what does it do? It takes sheep stomachs, it brings them back to their base level, so the scaffolding of the stomach, and they then apply human skin cells over the top of that. What does it do? It replaces skin grafts. Milk, we talk about selling lots of milk powder, but when we break it down into the enzymes and the capabilities and the compounds that sit in that milk, we're now producing health products. I should say also Aurora's growing about 17.5% a year. Context, so they're actually creating now specialist products. Why? Because people who are old want to live longer, people who are young want to look healthier. We have convergence of consumers. Lanico, wool, one of the base commodities now they've ionized it and they can use it in the air filters on spacecrafts, on the space station, and they've now got a strategic partnership with Unilever to provide for all air filters, sorry, get that out, on all air filters for that company. Based out of Hamilton, has 10 people in it. We need to recognize what is actually in our food system. We need to build these companies because we need the critical tension in that system to draw off that core food system. That economic tension at the moment isn't there, but the value that we've been creating in these businesses are. So we think about Aurora again, that's only using 100,000 sheep stomachs a year. But we could get that to 1 million. It goes from exploiting a waste stream to creating an economic engine into that core food system itself. I've done that very quickly, so I've tried to do that and keep it in time. This normally takes about an hour. So if you want more, there are substantially more in there. But what I would say is when we think about and step back think about our food system, in the past, we've always put more in to get more out. Now we'll be able to put less in to get more out. And more importantly, when we've done that, we've created harm. But what we're finding now with these solutions is that we can actually do good. And so when we think about where we are in the conversation at the moment around our food system, we're really comfortable with where the problems are. And we've got comfortable talking about for the last 10 years. But in actual fact, what we need to now do is get comfortable with where the solutions are and what do we want to do around how we can prioritize taking our food system into the next 10 to 15 years. Thank you.